This episode of Fluid Power Forum is sponsored by eShipping, a distribution chain management company offering transportation, warehousing, and technology services. Learn more at eshipping.biz.
Interest has been developed out of it. Career paths have been decided based on these kinds of things. It's very, very positive for students to get into the fluid power world.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lenke, and it's my job to interview interesting people who are moving fluid power technology forward. As always, if you'd like to be part of our show, we ask that you follow us on Twitter. You can find us there at the NFPA. And make sure to share interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is one of the ways that we source topics for our show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. We're on Apple Podcasts, we're on Spotify, we're on a lot of the other podcatching services. Wherever you find us, go ahead and subscribe and then give us a quick rating. Those ratings really do help promote the show and make sure more of our friends in the industry can join in on these important conversations. On today's show, our guests are Brian Steward and Saxon Ryan. Brian is a professor of agricultural and biosystems engineering, and Saxon is an assistant teaching professor, both at Iowa State University. And today we invited them both into our forum to learn more about ISU's Power Partner University status and how that is impacting their students and members of the fluid power industry. So Brian and Saxon, welcome to Fluid Power Forum.
Hello, excited to be here.
We're glad to have you both on the show. I'm hoping you can tell our listeners a little bit about your backgrounds. Brian, why don't we start with you?
Yeah, thanks, Eric, for inviting us to this. It's a real pleasure to be on your show. I can talk a little bit about myself. I've been around at Iowa State since 1999, so I sometimes say I'm part of past millennium. That's when I joined the faculty here at Iowa State. I was given an initial teaching assignment of teaching the fluid power courses in the department, and I've done that ever since. One of the privileges of being here in this department is being able to teach similar courses over a longer period, and then also being able to make improvement and make impact in that area. So I've been doing that ever since, and it's really been a pleasure to do that. I do other teaching. I do physical modeling and controls of dynamic systems course, mostly to graduates, a few undergrads in that course. And I did pick up a new course last fall, parametric modeling CAD,
Wow.
which has been exciting for me. And then I did teach a sustainable engineering course for about a decade, and then that dropped off a couple of years ago. I'm no longer teaching that.
Brian, where did you go to school?
Yeah, I grew up in South Dakota and went to South Dakota State University for my training as an electrical engineer.
Okay.
So my original background is in electrical engineering, and some people have told me that electrical engineers make good fluid power engineers. So the proof is in the pudding, I suppose.
Increasingly
we'll
so.
See if that's the case.
I think, yeah. There's a lot of hybridization going on between mechanical and electrical in the industry right now. So I think that's probably true. So were you always on an academic track? Is that was always what you wanted to do?
Not always. When I graduated with my BS, I did take a job in industry and worked there for 5 years. I was with a company in South Dakota that was doing controls for agricultural machinery. And particularly, we were controlling fluid systems. So like delivery systems for agricultural products like herbicides and fertilizers.
Right.
Yeah, I did go on and complete a degree at University of Illinois in agricultural engineering, and that put me on the trajectory to put me in this sort of job, this position.
What about that? I mean, what affected your trajectory, and why did you decide to go in that route?
Yeah, it really goes back to some experiences in my undergrad days. I was doing some tutoring,
Mm-hmm.
helping some other students learn engineering material, and I appreciated that and enjoyed that. I later went on and did um, a master's degree and served as a graduate teaching assistant, and again enjoyed that experience teaching and also the aspect of doing research, of
Mm-hmm.
exploring new areas, trying to uncover new knowledge and providing that to the industry.
Yeah. Great. Well, I appreciate that overview. Saxon, how about you? What's your background?
Sure. So I was led into my current position through graduate school, actually. During graduate school, I had the opportunity to teach, and as part of um, the graduate program requirement is to teach a course.
Mm-hmm.
And I actually got to teach fluid power in that situation, and I had a lot of fun with it. Originally, I was going back to graduate school um, to get my master's, to open up other doors, to open up other opportunities. But after I ran with that teaching experience, I had a lot of fun with it and wanted to do more of it. And so I continued teaching in graduate school until I completed my PhD and started a faculty position in 2019 here in the department. And I currently continue teaching fluid power. I also teach our advanced automated manufacturing course for our students, and then also a graduate course for advanced design and manufacturing
Mm-hmm.
in the department as well.
So it sounds like did you have any industry experience, or were you always on an academic track?
So I actually left after my undergraduate degree and worked for a while.
Mm-hmm.
I I worked in two different places. One, we did a lot of cold forming with wire form products. So there was a lot of hydraulics involved in cold forming different wire form or steel products. And then also I worked in a agricultural grain handling facility
Okay.
where we worked on development of equipment and other grain handling components, where there was some fluid power involved there. And while working, that's when I had decided. I had the opportunity come up. I had a professor reach out to me and ask if I was interested in graduate school.
Mm-hmm.
And I made the choice to go back to graduate school and start pursuing my master's. And then that's when all that happened, where I got to try to teach and had fun with it and continued on from there.
Yeah. Those are great background stories. Is it common for people to come to be in industry for a little while and then move into a teaching career in your experiences? I'm just curious if that's a common thread.
I'd say it's varied.
Mm-hmm.
There are some of my colleagues who have industrial experience and probably more that do not.
Mm.
Um, but it is varied. Yeah.
Yep. Well, tell us a little bit more about Iowa State. I'm sure people have heard, obviously, of the school, but give us a little bit more information, especially about its engineering and fluid power programs. How would you describe the school?
Yeah. Well, Iowa State was founded in 1858, and that was when the Iowa legislature became the first state to accept the terms of the Morrill Act,
Mm.
which, if your listeners are not familiar with that, this was an act that was passed to provide grants of federal land to found and to start schools that were specializing in agriculture and the mechanical arts. And I guess that's what they called engineering and technology in those days,
Mm-hmm.
mechanical arts.
Right.
So Iowa State was founded at that time, and it had a couple different names, but in the latter 50s, we were named Iowa State University of Science and Technology. So we are a land grant school, and I think we are pretty true to our mission which has three parts: discovering new knowledge, teaching that to students, and then also extending it across the state. So we have very strong um, programs and research in student learning, on-campus student learning, and then also extension of knowledge all across the state.
Mm-hmm.
Our department was the first of its kind in the world. Agricultural engineering, that was the original name of the department. And it was started by Professor J.B. Davidson, who's considered to be the father of agricultural engineering. And he had a goal of applying engineering principles to agricultural production. And particularly, he was an expert in agricultural machinery and the transmission of power, measuring power. And so that was how we got started back at that time.
Yeah. Go ahead.
Largely at that time, power was supplied with humans, then animals, and then steam engines, which really were a form of fluid power. So
Mm-hmm.
that connection with fluid power goes back a long time.
Yeah. And so, like, how many students are kind of in the program these days?
I mean, Iowa State University has just under 32,000 students, just to give you some perspective.
Yeah.
And we're a full-fledged engineering college, and have something like 14 different undergraduate engineering programs. In our department itself, we have 4 undergraduate programs and a total of about 600 students in that area. And I can describe those, or Saxon can describe those a little bit more.
Sure.
In our department, we've got four primary majors. We've got ag engineering, biological systems engineering, and then we have also our more applied engineering programs, our ag systems technology and industrial systems technology. And so we've got about 650 students just in the department overall.
Mm-hmm.
And most of those students are going to be exposed to fluid power throughout their degree programs. And then we also have about 80 graduate students at the moment. And depending on what those graduate students are working on for research, or what they're doing in their program, they may also be working on fluid power specific research, or helping to teach fluid power courses. And from the faculty perspective, we've got 39 faculty, we've got 11 program staff, and then also 36 research staff. So we've got a fairly significant department here.
Yeah, there's a lot of talent on both the faculty and the student side at that institution. There's no question. I mentioned in the opening something called the Power Partner Program. That is something that NFPA helps to manage, and it recognizes schools, universities that are deeply engaged in fluid power education programs and in working to connect their students to companies in the fluid power industry. And Iowa State is one, I think, of 3 schools right now that have earned that designation, if you will. And we want to talk more about kind of what kind of activities that helps facilitate on your campus. But why don't we start with how this journey started to become a Power Partner University? Brian, you've been there a while, I know. How did your school first get connected to NFPA? Do you remember that origin story?
Well, yeah, I do. I was brought on to have this teaching assignment in fluid power, and frankly, it was a new area to me. So at that time, I was reaching out and looking for opportunities to learn more. And in the early 2000s, NFPA was really reaching out to work with academia. And there were several meetings that where we were invited to come and take place and start to understand the industry and understand NFPA. So I've been engaged with NFPA since the early 2000s, and it's been a very good partnership through the years. NFPA supported at times some research initiatives that I did, some grants, and it's just been helpful overall. So it's really been a long-term partnership.
Is there, yeah, I remember, there was a time where, as you said, NFPA was certainly either helping or directly providing funds for research projects on university campuses. That was part of an initiative to kind of generate more interest in teaching fluid power. Do you think it had that effect on the campus there?
Fluid power goes back before me as in terms of being an important part of the curriculum. There were some real giants in the area. Some of my predecessors, and so they were teaching fluid power courses before I got here, and had been doing that for some time.
Mm-hmm.
So there'd been a good relationship with local industry, and so it really has gone back, even before me, where it was important. If you look at machinery, and we're really focused on off-road machinery here, agriculture, construction, uh, hydraulics particularly, is so important to that industry.
Mm-hmm.
And that's where many of our graduates will tend to go, to OEMs. Uh, and so there's been that feedback of this is an important technology. Our students need to know it. And so that's been recognized for really a long time.
So the Power Partner Program, as I said, asks universities to participate in a variety of different activities. There's a Speakers Bureau program. There's something called the Fluid Power Vehicle Challenge, which I think we'll talk a little bit more about a little bit later in our conversation, as well as fluid power clubs that help host student and industry connection events on the campus as well. It's a lot of activity. I don't know, can Brian or someone talk through a decision process for like deciding to move in that direction, and then how long did it take to onboard kind of all of that activity into what the university does?
Well, probably it'd be best just to go back to walk through it step by step. Uh, and Eric, the year, it seems like it was about 5 years back
Mm-hmm.
when NFPA started doing the vehicle challenge. I was asked to be a judge at that year's competition, and I really didn't know what the competition was all about at all. And I remember right before being a judge, I started looking through the rules and figuring out what is this competition anyway. And,
Mm-hmm.
and that's when I saw that it was a human-powered type of competition where the students are doing design of vehicles that are human-powered, and then they're transmitting power through hydraulics at some place along the line between the pedals and the wheels. And I became a judge, and so that was my first exposure to this event, and that was pretty interesting. Really good design project. And so then the next year we started a team here at Iowa State, and got a bike on the course for the first time. There's a little funny story about that if you want to hear that.
Absolutely.
Well, the students got their bike together, and it was running just fine inside the halls here in our department building, and so it was working just fine. And they got out to the course, and there happened to be a slight incline. It's a pretty flat course. You're familiar with it,
Yeah.
Eric.
Right.
And in Iowa in April, there tends to be some wind. And so with the slight incline and the headwind, they really couldn't get off the line for any of the competition. And we learned a lot through that process.
It really is a a real world experience in a lot of ways. The process of kind of designing, building, and then actually, I don't know, performing would be the right word, making it work in a real world setting. Maybe we've reached a point here in our discussion where we just need to take a quick break. But why don't we do that, and then we'll come back and talk a little bit more about Iowa State's recent experience in the Fluid Power Vehicle Challenge. NFPA's latest edition of the U.S. Fluid Power Industry Brief is now available for download from the NFPA website. The brief is a convenient compilation of industry facts and data, which can be used to understand and promote the growing fluid power industry. You can use the brief to encourage a student to pursue a career in fluid power, to educate your network on the value of your business and industry, or just better explain to a family member what it is you do and why you love it. To view and download the brief, head to nfpa.com and look for the U.S. Fluid Power Industry Brief under the Industry and Stats tab. Go there now, download that file, and share it with anyone you think would benefit from our content. Working together, we can promote and grow the fluid power industry. All right, we're back from the break. I'm talking with Brian Steward and Saxon Ryan, both professors at Iowa State University. And Brian, you just told us a story about some struggles that the Iowa State team had in one of their first appearances in our Fluid Power Vehicle Challenge program. We have a much different story to tell about the student team in the most recent challenge, which took place in April of 2022. The team did much better, if I recall. In fact, they took first place in the competition that we had just a few months ago. What do you think the difference was between the two events that you just described?
Well, we've certainly gotten some experience. We've been in the competition every year since that initial time I was in it. I talked about before when we didn't get off the line, and so we've learned quite a bit through the process.
Mm-hmm.
The other thing is Saxon got involved and has been helping me mentor the team. So I think probably that's the biggest reason for our success is we got a better mentor than me.
Very humble. Well, great.
No,
Well, then let me ask Saxon. Just maybe from, I'm sure our listeners are trying to figure out what we're talking about. So, like, how many students are we talking about? How many students participate on this team?
So we had 5 students. Is that right, Brian?
Yes.
Yeah, we had 5 students on the team. And any credit that that I get for any kind of success does have to go back to Brian, because all this started way back when I took his fluid power course when I was an undergraduate.
Okay.
And and so any success I have will go back to Brian on that. But no, we had a lot of fun this year. The team did do very well, but I think again there was a ton of learning this year with the students working on the bike, trying to get things done. Anytime students are working on a project and applying these kinds of principles they learn in class,
Yep.
they start to see some real value in it and get really involved in it. But that can take more or less time depending on the other things that are pulling on students. There's a lot of demand for students to do many different things, and so it can be really challenging for the students to pick something to move forward with, like the Fluid Power Bike Challenge, and say, no, this is the project I'm going to work on for this next year.
Yeah.
When there's so many other opportunities out there. And so time management is a very difficult thing when there's so many opportunities for students to be doing all these diverse activities. But yeah, the students, they were running up pretty close to the deadline, and we were a little bit concerned. The students were concerned about getting some of their design aspects to work, but they implemented some lessons learned from previous years' bikes, and what they were trying to do was essentially have as much free rolling as possible, remove any of that drag. And so their power transmission design in disconnecting um, disconnecting our pumps and motors when they weren't being in use, so that there's a lot of free rolling, so the efficiencies were increased.
Mm-hmm.
That really helped in the efficiency, primarily in the efficiency challenge. Um, but yeah, there were some difficulties along the way in getting some parts ordered, getting things in on time, getting things manufactured on time, and then just trying to keep the design simple enough to ensure we could manufacture
Yeah.
some of these components that belong on that bike. But I think everything came together right at the last minute for the students to be very successful
Yeah.
this year.
Hey, Saxon, I want to zoom in on something you said a little while ago, and that was, um, they are applying concepts that they're learning. I mean, Iowa State is as we've talked about, you actually have fluid power classes in your curriculum, and not every university has that. So, but still, the students that are participating in the vehicle challenge, this is an opportunity for them to get hands-on with actual technology and to apply the design concepts that they're learning in their classes. How valuable is that? I mean, do you get feedback from students on what that experience is like for them? Because I don't know that they have those experiences in any other way, do they?
So those experiences, so I'll speak briefly from personal experience on
Sure.
that. When I first took that fluid power course way back when with Brian, it was just another required course.
Mm-hmm.
And I was just walking through it, doing the things that I needed to do. At the time, there wasn't a fluid power club or the bike competition that I was participating in. That wasn't something that, well, maybe it was going on at the time. I wasn't aware of it if it was. But it wasn't until after I graduated and went into the workplace and saw the value of fluid power, and understanding these fluid power concepts. And so, even though I was in the course, learned the material, did everything I needed to do, um, I didn't really see that value until I actually started using it
Right.
in a situation. And so I think now that these students are getting access to a competition like this, they see that value much sooner and can understand their interest and realize their interest much sooner in the fluid power world. And so I think, a couple of things. One, providing a lot more hands-on laboratory experiences in the class, and providing other events, where students can interact with fluid power systems and also interact with fluid power industry members to realize the value of the things that they're learning in that class. It's very powerful.
Yeah, that connection to industry is also a key piece of both the challenge program and the larger Power Partner initiative. That the vehicle challenge is a conduit, if you will, because there are industry members who are participating as either part suppliers or even judges or mentors to the student teams. Can someone describe the value of that, or at least how industry interfaced with Iowa State in this competition?
I like to give the students more opportunities to interface with industry. So, for example, in my class, they do a design project. This is the fluid power engineering class.
Mm-hmm.
They do a design project, which is not. It's a pencil and paper or computer simulation type of project. So they don't build anything. It's I think always building something is a better experience, but this is still a valuable type of project. And what I do at the end of the semester is I bring in uh, local engineers to evaluate the final project. And what that does to the students is pretty amazing. First, it maybe puts a little fear in them, because somehow real engineers they're more real than us faculty members. We're kind of not really real or something. I don't know, but they really that pushes them to move their game up
Mm-hmm.
quite a bit and bring their A game to to the table when they do their presentation. So I just think that interaction with between students and engineers who are practicing in industry is very invaluable.
Mhm. There are several ways to facilitate that. You just described one of them. There's also student industry connection events that we try to host on our Power Partner campuses. One has been recently held at Iowa State, has it not?
Yes, we had an industry student connection event last fall. Yeah, it was the first time we did it, and it was the last thing in terms of the list of requirements that we needed to complete to
Mhm.
become a Power Partner University. We worked with uh, some of your staff at NFPA, and then also some of our career services people here at Iowa State to help organize that. And we had several companies come, and they had some breakout sessions where they presented what they do in their company, and really very high quality presentations, helping students understand fluid power.
Mhm.
And then we had just a networking reception with the companies and the students, a little bit of food and drink, um, and that was all very positive. So it was a very positive event for, I think, both for students and for the industry representatives who came.
The intent is to not only spark interest in fluid power as a career path, but to actually make connections to potential companies that can help make that happen. Did you see those kinds of connections actually taking place?
So I'll speak to a couple little experiences from my perspective
Mhm.
briefly. I know Brian has some experiences with that as well. Um, so I've actually had a couple students reach out to me directly after taking fluid power. A lot of students who take the class, they come from an agricultural background, or maybe they even come from a rural back or a they've grown up in other areas where they don't have access to fluid power piece of equipment, but they're familiar with construction equipment and ag equipment. So it's kind of across the board. Now, typically in my class, I have a lot of interest from students who've grown up in an agricultural background because they've grown up working with agricultural equipment with fluid power on it, and they've always known that the hydraulics are there, the fluid power is there,
Mhm.
but they don't really understand what that is. Um, and when they start to take this class, regardless of the background they come from, they say, "Oh, that's how that stuff works," or "I didn't know fluid power was in that, and I'm interested in doing that."
Mhm.
And so I've had a handful of students who have reached out to me and said, "Hey, this is really what I think I want to do with my career going forward. How else can I get involved? What else can I do to learn more, to become more involved with fluid power?" And I think those students who develop that big interest, whether it's from the class or from the Power Partner events, um, they start interacting with these companies. And I've had a handful of students who have taken either internships or jobs in industry from across the board with different fluid power industry members.
Yep.
And so interest has been developed out of it. Career paths have been decided based on these kinds of things. It's very, very positive for students to get into the fluid power world.
That's great to hear. It's a big part of what we're trying to accomplish is to kind of create a reliable workforce pathway for our industry through these partnership activities that we do with schools like Iowa State. So it's fabulous to hear that those connections are actually being made. So it's a positive change in people's lives, which really helps everyone, both the student and the school and the industry. So that's great. So I'm curious, what you guys see as kind of the future for either fluid power or the Power Partner program on the ISU campus. What's next on the horizon?
Well, a couple of other aspects of that should be mentioned are the Speaker Bureaus program, where
Mm.
NFPA um, helps bridge connections between Iowa State. Particularly, we have a Fluid Power Club and speakers, and so we will often have speakers come in and talk about what they're doing, and they provide very interesting presentations. We had a speaker last fall who really talked about what he was doing right now, and the lessons that he learned being in the industry for many years. And
Hmm.
students were just hanging on, seemed like on every word. He was very dynamic, and also just giving them a picture of, well, what's important out there to be successful in the workplace. And students are really enjoying hearing from that. But a couple of years ago, we had a student that Saxon and I mentored, working on some projects in our fluid power lab, and we recognized this was a very good student. So we had a speaker from the NFPA Speaker Bureau come over, and he actually flew over. He's the president of that company, and
Hmm.
uh, at the end, he was looking for a ride back, and so I told the student, "You give him a ride back," and I sort of keyed up everybody. This is a good student, and so a little while later, he got a job offer for this company. So just that sort of high touch sort of situations is what this is bringing about, and I think that's really important with today's students to
Right.
have those sorts of experiences.
That's a great testimonial, I think, for any NFPA member company that's listening that would like to get involved and benefit from those kinds of connections. The industry, like a lot of industries, is looking for engineering talent out of universities, and this is a great way to make those connections. It sounds like. I wonder what either Brian or Saxon you would say to a colleague at another university that's not participating in Power Partners. Why should they consider going down a similar track that you guys have?
I think this is a wonderful way to give the students a pathway directly into something they may be interested in that they may not currently know that they're interested in until they start to get involved and interact with industry members who are in it, and start to go down that pathway to discuss opportunities. It's a wonderful way to connect with industry members for the students, and also that's a win-win for industry and the students themselves to make that connection, because industry can also provide some feedback in the things that they're doing. They provide that real on the ground, working in industry for the last 20 years, information and practical information to those students when they come to talk about things, when they give their presentations or do these Power Partner events. It's a wonderful way to get those two groups interacting with each other. It's a very supportive environment for both sides.
I'll just add that all of us university faculty members are busy, and industry people are busy as well. And so the piece that NFPA provides here with all of these programs is really to be a catalyst to forming these sorts of partnerships, and be very supportive and trying to help that out. And I think as we move into the future, we really need to continue to look for ways that we can partner and leverage each other's strengths. And this is just a well-developed program to make that happen.
Fantastic. Well, we certainly appreciate the partnership that we've been able to develop with both of you and with Iowa State, and we look forward to seeing that grow and bringing it to other schools in the future. So I want to thank you both. That is going to wrap things up for this episode of Fluid Power Forum. My thanks to Brian Steward and Saxon Ryan, who have been my guests. If you want to connect with them and learn more about what's going on at Iowa State, you can do that via email, and we'll be sure to put their email addresses in the show notes for this episode. If you'd like more information about our Power Partner University program, you can learn more on our foundation's website, and that is nfpafoundation.org. Remember, if you like our podcast, please follow us on Twitter and make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. And to see the latest fluid power technology and learn from industry experts, make your plans now to attend IFPE, the International Fluid Power Exposition. Our next show will be in March of 2023 in Las Vegas. For more information, visit ifpe.com. This is Eric Lanke of the National Fluid Power Association, reminding you to join us next time in the forum.